So now the second extensive form, le R34. Again, the same questions. How many information sets for n? How many information sets for Baz? Well, it's fairly simple. In this case, it's a simplified version. So the moves, the positions where there's only one option have been removed. So in this case, we only have 1 and 2 information sets for n, both containing 3 positions. And for Baz, it's the same. We have 1 here, and we have the other one there. So let me label them again. So let's put in red 1 for information set number 1. And a red 2 for information set number 2. Red 1 means n has a card of level 1. A red 2 means n has a card of level 2. And if n has a card of level 3, of course, she will keep. So there's no reason to make a decision. So this is excluded here already. And we do the same for Baz. So if Baz has a card of 1, we put in a blue 1, a card of 1, and of course the 1 refers to this information set here. As you can see, both have a 1, and here 2 has a 1, 2 has n has a 2, Baz has a 1, so this is this position, and here n has a 3 and Baz has a 1. So this is information set number 1, and information set number 2 is the other one. Of course, you are free to label them as you want to, but I think this is a little more systematic, because now we know information set number 1 for Baz is where she has a 1. Information set number 2 for Baz is where she has a 2. Now for the pure strategies, how many pure strategies do we have? Well, we have to look how many options in information set 1. We have 2 of them. How many options in information set number 2? We have 2 of them. So that means we have 2 times 2. We have 4 pure strategies for n. We can do keep, 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 swap, swap, keep, and swap, swap. And the same for Baz. 2 information sets, 2 options each, 4 strategies. It's keep, 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 swap, swap, keep, and swap, swap. So it's a 4 times, the normal form is a 4 times 4 matrix. Well, the next question was, what is the outcome if n plays kk and Baz plays sk? Kk. So let me write it down so that I don't forget it. Kk versus in black, sk. So red, the n plays kk and Baz plays sk. What happens in this case? Well, again, we have to simulate the game as before. We have to check out all possibilities for the random move, which are 9 possibilities now, as you can see, and check in each case what happens there. Before we do this, let me just highlight again the moves which are done. So n will keep in her first information set. So this is what she does. Keeping, keeping, keeping. And in the second information set, as you can see, she also keeps. So she always keeps no matter what she gets. She keeps a 1, she keeps a 2. Maybe a little silly, but that's the way it is. Now Baz will swap in her first information set. First information set is here. So she will swap in this one. So you keep, look at this number here, swapping, swapping, swapping. And with number 2, information set number 2, she keeps. This looks a little more reasonable. You will swap a low card, obviously, you throw it away, but a middle level card maybe you keep. So this is what Anne does in this particular pair of strategies, and this is what Baz does. And now again we have to go through the list of all possibilities. So number one, this one. What happens if you arrive here? Well, we go keeping and swapping, so the payoff is negative 0.8, 0.8 again. Keep in mind these are expectations based on the cards which are left in the deck. So this is already a rather abbreviated analysis. So we have, with probability 1 over 11, we have an outcome of negative 0.8, 0.8. Let me write it down. So probability is 1 over 11. And the outcomes are, let me see, negative 0.8. And let me also make a little blanks here, and 0.8. So, oops, maybe I make it a little smaller. 20 might be good. This is what happens in one of the cases. Next one. What about if we arrive here? Well, we arrive here and keeps, Baz keeps. We get negative 1,1. What is the probability? It's 4 over 33. So with probability 4 over 33, outcome will be negative 1, 1. So let me write it down. 4 over 33. You see, it's a little larger than 1 over 11. Outcome will be negative 1 and 1. Negative 1 and 1. So we put it in. Okay. Next one. 4 over 33 and keeps. Okay. Then the game is already over because Baz has a card of 3 and will never swap in this case. So we have negative 1,1 with a probability of 4 over 33. So negative 1, 1 again with 4 over 33. Okay. Goes in here. This is the third option. Number 4. 4 over 33, keeping, swapping. Negative 0.1, 0.1 the expectations here. So let's put it in, 4 over 33. And the outcomes are negative 0.1, negative 0.1 and 0.1. So we put it in. Next one, number 5. 1 over 11 again. Keeping, 0, 0. So we have 1 over 11, 0, 0. 1 over 11. And we have a 0 here. And we have a 0 for Baz as well. Number 6. 4 over 33. Keeping again. Baz will not swap because she has a 3. So 4 over 33, negative 1, 1. 4 over 33, negative 1, 1. Next one. 4 over 33, we arrive here. You see, these are the 3 cases where Anne is not even asked because Anne gets a level 3 card. And of course she keeps it. Baz swaps in this case, so we have 4 over 33 times 0.7, negative 0.7. 4 over 33, 0.7, negative 0.7. You see, eventually Anne gets positive values, but only in these cases when she has a 3. Otherwise her expectations are not positive. number, well, almost done. 4 over 33. Bears keeps, it's a 1 negative 1. So again, a good case for Bears. Sorry, a good case for n, of course. 4 over 33 times 1 negative 1. So again, in this case, n will win. And then finally, the last one, number 9, 1 over 11 times 0, 0 again. Maybe I just copy it from here because it's exactly the same as it was before. Copy, so both get a 3. In this case, well, not really much happens in this game. So these are the 9 cases for random moves, the 9 probabilities which add up to 1. And here are the payoffs for n in these cases, and here are the payoffs for Bears in these cases. So what is the payoff for n in this case? So let me just add all these numbers. Let me put it somewhere where we can see everything. So here the payoff is 1 over 11 times negative 0.8 plus 4 over 33 times negative 1. Let me put this all in parentheses maybe to make it a little. And another 4 over 33, again in parentheses, maybe 4 over 33 times negative 1 again. And then let's go into the next line. Let me put it in all the parentheses here to make it really clear what we do. Also, it looks a little awkward in this way. We have another 4 over 33, 4 over 33, and we multiply by negative 0.1. We have 1 over 11 times 0. Okay, this is not so interesting. We have, of course, this is a plus between, sorry for that. And we have another 4 over 33 times negative 1. And then we go one line further, and we have 4 over 33 times 0.7 plus 4 over 33 times 1 plus 1 over 11 times 0. So let me put this formula in. This is the payoff, the expected payoff for n, looking rather complicated. So this is what n will get. N is red, so maybe we color it red. So n's payoff, if both players play this amount of money, is this amount, and if we multiply this, then we get, well, it's difficult for me to calculate, so I will put it on the formula sheet and post it on Moodle.